we're going to start by squaring both sides. We notice that the radical is already isolated by itself. Squaring the left gives us 6t plus 7. Squaring the right gives us a FOIL problem. So no change on the left, 6t plus 7 stays, and on the right, first term of FOIL, t squared. Outer and inner are both 2t, and they add together to make plus 4t, and the last term of FOIL is positive 4. I want, because this is a quadratic equation, to set this all equal to 0, so I'm going to subtract off the 6t on each side and subtract off the 7 on each side. The left side is 0, and we have t squared minus 2t minus 3. This is going to now factor into t minus 3 in one parenthesis and t plus 1 in the other parentheses, and it appears that temporarily our two solutions are 3 and negative 1. And I say temporarily because we need to check these answers. Substituting the 3 in, 6 times 3 is 18, plus 7 is 25, the square root of 25 is 5. So the left side is 5. 3 plus 2 is 5, the right side is also. Substituting in negative 1. 6 times negative 1 is negative 6, plus 7 is 1, and the square root of 1 is 1. Negative 1 plus 2 is 1 also, and so these two answers stand as is, and we have two solutions to this problem. Here we go with the next problem. Right here. Looks like we're doing pretty much the same exact thing as the problem above, except this time we need to isolate the radical. We need to subtract that 7 off to the other side. That gives us the square root of 2m plus 1 equals m minus 7. Then we are able to square both sides to lift off that radical on the left. And lifting it off, we just have 2m plus 1. On the right, FOIL problem again, m minus 7 times m minus 7. Okay, let's do that FOIL on the right. No change on the left. We're going to have m squared minus 7m and minus 7m make minus 14m plus 49. It's a quadratic equation again. That means it needs to be set equal to 0. So I'm going to subtract a 2m off of each side, and I'm going to subtract off a 1 on each side. We now have 0 equals m squared minus 16m plus 48, which will factor into m minus 12 times m minus 4, and we now have m equals 12 or m equals 4, which we need to check. So here we go. 12 substituted in, 2 times 12 is 24, plus 1 is 25, which square roots to 5. 5 plus 7 on the left makes 12, and on the right we're substituting in 12, so 12 checks. Now let's try the 4. 2 times 4 is 8, plus the 1 is 9. Square root of 9 is 3, plus the 7 should make 10, but equals 4 instead. That 4 does not work. What we do is we call it a name. We have a name for it. It is called an extraneous root or an extraneous solution. Basically, it's like a weed that pops up in the middle of the problem that you don't want to have there, and we want to go weeding and get rid of it. Now, why does this occur? Well, let's talk about this for a moment. When you first learn to solve equations like x plus 4 equals 9, very easy, it only had one solution of x equals 5, and that's because it was a linear equation with x to the first power. When we started to solve problems with an exponent in them, x squared equals 9, that's where we get the plus and minus 3, x squared minus 9 equals 0, and so I'll just write plus or minus 3 there. X to the second, this was a second degree equation with two solutions. Well, in the process of solving these equations, these radical equations, you are squaring both sides. And squaring both sides is raising the degree of the equation. And when you raise the degree, you're introducing more solutions in. Sometimes they work and sometimes they don't. And in this case, the 4 was a weed or an extraneous solution that showed up that we needed to get rid of.